To sum up Chapter 6, Sequences and Series, we are going to show the previous objectives. After completing this chapter, we should be able to generate a sequence from the nth term or from a recurrence relationship. We should also be able to know how to find the nth term of an arithmetic sequence un, and we define the arithmetic sequence and how the term might be in this sequence. We should know how to find the sum n terms of an arithmetic series Sn. We should solve the problems on arithmetic series using the formulae of un and Sn, which means that we have solved problems regarding to sequence and series concepts. We should know the meaning of the symbol sigma, which is the summation of the series. We learned in this chapter about Carl Gauss, a mathematician who found a way to calculate large term summation of arithmetic. And that was to apply the summation of integers from 1 to 100. And we learned the proof of this sum. To make a summary to all of the ideas, a series of numbers following a set rule is called a sequence. Each number in a sequence is called a term. The nth term of a sequence is sometimes called the general term. A sequence can be expressed as a formula for the nth term. For example, un equals 4n plus 1, where n has different values. A sequence can be expressed by a recurrence relationship. For example, the same sequence can be formed from un. We mentioned in the recurrence relationship that there is a condition that must be fulfilled. First, you have to specify what is the first term inside the sequence and what is the value of n, which n is equal to or greater than 1. That was the introduction of this chapter. We move to another sequence. A recurrence relationship of the form uk plus 1 equals uk plus n. T is called an arithmetic sequence where n is a constant. All arithmetic sequences can be put in the form. We learned the general formula of the arithmetic sequence. The nth term of an arithmetic series is given in the form a plus n minus 1 in parentheses times d, where a is the first term and d is the common difference. Finally, we use the formula for the sum of an arithmetic series, and we learned the proof of the two formulas. Where a is the first term, d is the common difference, n is the number of terms, and l is the last term in the series. You can use sigma to signify sum of, and you can use sigma to write series in a more concise way. So instead of writing a long expression, we can summarize it by a sigma symbol. These are the most important ideas that you have to keep in mind, not just for this course, even for an IQ test and for math riddles that could be found on the internet. Or applications for some jobs that contain questions related to sequences. For example, to find the pattern or to complete the sequence or series by figuring out the rules. So the importance of this chapter is not only for the short term, you must keep its information for later use in your daily life. You can return to the book on page 208 that contains mixed exercises for all the ideas that summarize the sequence, series, and the sum. And solve the problems to check up if you are able to apply the ideas you have learned. So now we are done with chapter 6 that talks about sequences and series.